So that is your full text search. And then the next one is your vector search. A lot of advanced users, they want to use efficient methods to semantically search for similar items. So suppose like if I have two documents and I want to just find out what are the similar documents that are related to this. So if you need efficient methods to retrieve semantically similar items from large scale databases, vector search is your way to go. So embedding algorithms will allow you to map the data items into continuous vector representations. And basically, with vectorized search, what happens is the relationships and the semantic structures are already defined, which means when you are going to search for something, it is going to be easy for you to search that. So vector search is a new capability in Azure AI Search, mainly used for indexing, storing, and retrieving vector embeddings from a search index. And keep that in mind if you are building RAG-based architecture applications, which is retrieval augment generation, you will be using vector search a lot because that is a powerful search for your RAG architecture pattern. And of course, we'll talk about that pattern shortly. So there is a lot of off the shelf products which can support the vector search, and also like our Azure AI search, it also supports the vector search. And you can easily integrate that with semantic kernel, LangChain, Azure Open AI service, as well as your AML, Azure Machine Learning Prompt Flow. So typically, how does the vector search flow works? You basically generate your vector embeddings, then you create an index in the Azure AI search, you add your vector fields in there, you load your vector data, and finally you query your vector data. It's as simple as such. This is the flow of activities that happen as part of your vector search. The key things that vector search can do is like you can do with the search similarities, multilingual search, and also you can have a vector database available in there. Basically, it will allow you to just turn the text into vectors, and that's what you'll do. You just create the vector embeddings, you create an index, you add the vector fields, you load the vector data, and finally you will end up querying the vector data. So how do you vectorize the data? Either you can generate vectorize or generate embeddings using the models from OpenAI, Azure OpenAI, or other providers, which will give you the vector representations of your data. And also you can do integrated vectorization, which is basically adding data chunking or text to vector embedding skills as part of your Azure AI search. So Azure AI Search also provides the ability for you to do vectorization and also store the data inside there. We saw the embeddings model, right? So the embeddings model help you to convert the data into vector representation. Vector representation is nothing but converting the text into floating point numbers, and you will be able to do that with the help of embeddings. And why do I need embeddings? Because vectors are the universal way of representing the data. Okay, so whether you have got massive text documents, images, audios, or video clips, all those things can be represented in vectors. And you can construct these vectors in a way that you can directly compare them with each other regardless of the format. So I can compare between an audio file and a video file with the help of vector representation, because at the end of the day, behind the scenes, they are basically numbers. Often when we are building applications, right, we always look for the similarity between the different items. And these items could be either documents, or it could be sentences, or it could be images, audio files. Sometimes direct comparisons or will work out. Like for instance, looking for exact word in the sentence. But in some scenarios, like you can't use a one-to-one. Like if I look for the word open source, I don't want to use exactly looking for the word open source. Sometimes I need to look at, oh, are there any items that are semantically similar, or like the way how you represent them in text or pixels, whether they are, there is a similarity in that. And that's where vector search comes into play. So embeddings are nothing but it is a vector representation of the data, so that the vectors will be as close together if they have similar meaning. So the numbers are will be close together if they have similar meaning, and they will be far apart if they have different meanings. So if you take this example here, right? So you have data sources, whether it's images, audio files, video files, or text. You transform them using the embedding model and into vectors. You index them in the vectorized database like an Azure Cognitive Search. And then when you are asking for anything, then you are searching for something. That search data, text data will be converted to vectors, and it will be searched with the vector representation that is available in Azure Cognitive Search. Then the results will be ranked and it will be provided to the end user. So this is as simple as such around how the relevant objects are searched for with the embeddings model. So when you are choosing an embedding model, you have to be considering the model characteristics and implementation factors. For instance, if you are looking for the model characteristics, make sure that the model aligns with the data type and your specific application. You should assess the model performance, because how long it takes for it to convert your text into vectors, and determine whether they are context aware embeddings are necessary for your text data, and ensure the model balances the complexity with performance. So that's why if you want to choose a right model, then you will be looking at all the characteristics. Text embedding ADA 002 is what OpenAI service is recommending for text embeddings. And the Azure AI Vision Image Retrieval API is recommended for image embedding. So if you have images need to be converted to vectors, then use the Azure AI Vision Image Retrieval API. Whereas the text embedding ADA 002, mainly you can use it for text embeddings. ANN, which is Approximate Nearest Neighbor Search. So this is again an AI driven approach. Mainly you can use it to find similar items within a specific search radius. And how this is approached is you can use approximations again instead of exact matches. And then you will be able to leverage AI techniques like locality sensitive hashing, tree based methods, and neural networks, so that you can identify what are all the nearest neighbors for a particular search text. So the benefits of this ANN, or the approximate nearest neighbor searches, you can deliver more relevant results in comparison to the traditional search methods. And also the user experience will be also good, because now you can obtain faster search results with the ANN search pattern. So I talked about the cosine similarity, right? So the cosine similarity is the choice of distance function, basically like how much two texts are apart. You can easily identify it by the cosine similarity mathematical format. But there are other patterns also available like dot product, Euclidean distance, angular, Jaccard. But I think the open AI, they came back with and said like the cosine similarity was the one that is more relevant and it is usable to what they were recommending. So basically, what is the process to get started with vector search? So you take the different data sources, you gather all them, you ingest the data. From that, first thing you will be doing is you generate embeddings of that data. So because they all will be in text or images, right? So you need to convert them into embeddings, and then you add the index to your embeddings, and then you create your vector configuration, and then you create embedding query, and then you can search with your vectors. So simple process, you index, and then when you are querying, then you convert the query text also into embeddings and start searching within your vector database. You can also when you are creating the search index, you can add the vector search configuration, the vector field to the fields collection, and you can load the vector data for indexing purposes. So you can start pushing the data to an index. So there is no restrictions on what is the data source type, the frequency of execution, and so on. You can upload documents either individually or in batches in Azure AI Search. And as I said, connectivity and the secure retrieval of documents are fully under your control, because you will be doing this within your Azure portal. And then create the index within the Azure AI Search once the data is imported. Then you create a vector query in Azure AI Search just to make sure Like you provide a query and that query will be converted into vector, and then it is going to search the documents based on whatever vector that you are passing. This is a simple example for a vector query request. As you can see, like you will be sending the text that needs to be converted into vector. This would be the response that you will be getting along with the, so when you send a request, you get a query response along with the search score. And this is how you will be just then you will be representing this JSON in whatever natural language format that you want to represent to the end user. Scenarios that vector search can support is vector search for text. You can encode the text using embedding models such as the OpenAI embeddings, and you can retrieve the documents with queries that are also encoded as vectors. You can do vector search across multiple data types. So for instance, whether it's images, text, audio, or video, or it can be a mix of them, you can do a similarity search between them. It supports multilingual search, where you can use a multilingual embeddings model to represent your document in multiple languages, regardless, like you can try and search for in one language, but it can be searched across multiple languages and retrieved. Then you have the hybrid search, where you will be implementing the vector search at the field level. So which means you can build the queries, which includes both vector fields and the searchable text fields. You can also have a filtered vector search and as well as a vector database, which is basically an Azure AI search. If you take the Azure AI search, it is actually a vector database, and you can use it as a long-term memory or an external knowledge base for your large language models. There is another technique which is currently in preview is the integrated vectorization process. So just I'll quickly introduce you to what it is because it is currently in preview. There is a lot of changes that it may go through, but it is good to understand what it is. The integrated vectorization, basically it adds data chunking and text to vector embedding skills in the indexer based indexing. So basically what we are talking here about, sometimes if you want to chunk the information into multiple chunks and then you want to convert that into vectors, you will be able to do that. And you can do chunking and vectorization. And also you can bring your own Azure OpenAI service endpoint into here in Azure AI search. So now you can, rather than doing vector data, you can bring in the AI search endpoint to Azure AI search, and you can just do the chunking as well as the vectorization within Azure AI search. So basically, this is what the component diagram looks like. So you can use any supported data store for the indexer based indexing, and then an index that specifies the vector fields and the vector definition will be organized. A skill set like a text split skill will be used for data chunking. And of course, an embedding model, which you use in the Azure OpenAI service, you can use it to convert the text into vectors, and then the vector data will be stored in the Azure AI search. So basically, in which scenarios you will be using integrated vectorization is, suppose if you want to subdivide large documents into chunks, right? Because the GPT will have some limitations around how much tokens that you can send. So you can use integrated vectorization for that capability. So that's one of the important reason why you will be going for integrated vectorization. So we talked about full text search, we talked about vector search, and then we have got what we call it as a hybrid search. So hybrid search is basically you can, for a single search request, you can ask for both full text search and vector search to happen in parallel. And then you can merge the query response and you can score the rank using reciprocal rank fusion. You may be wondering, why should I do that? I can just do a text search or I can just do a pure vector search. What is this hybrid search is going to give me? So let us look at this table. So vector search is good, but hybrid search is even better. We'll look at why. So if you take the full text search, it can do exact keyword match, it can do a proximity search, and it can do term weighting. But if you take a pure vector search, it can do semantic similarity search, multimodal search, as well as multilingual search. How can I get the best of both? If you do a hybrid search, which is including your BM25 and ANN ranking along with that, basically you take the search results, you take the, when you someone issues a search query, right? You go and do a vector search, you go and do a text search, bring the results together and sort them based on the BM25 and ANN mechanism. And then you can provide a filtered response back to the user. And so once you do that, then you need to do the ranking, right? Because the combined ranking, each one of them will be ranked by its own search mechanism. For the combined ranking, we'll be using what we call it as RRF, which is reciprocal rank fusion. It's a technique for combining the results from multiple search strategies, and then you can still provide search relevance and ranking. And so this is the hybrid search will be the best way to go. And hybrid search with semantic re-ranking is much more best approach, because in this case what happens is you issue a text search, you issue a vector search, they are all pre-sorted by the search results, bring them together, apply the RRF ranking, and then finally like you can provide the search results back to the end user. So your hybrid search is much more powerful rather than your independent vector search or the text search, because you get the best of both. Elasticsearch is also another type of search where it is a distributed search and analytics engine which you can use. Sometimes like when you use tools like Logstash and Beats, they facilitate collecting, aggregating and enriching data, and you can store it in Elasticsearch. Like Kibana, it's a visualization tool which will allow you to visualize the data that is stored in Elasticsearch. Again, if you want to use Elasticsearch, that is also something that you can consider.